Okay, here we go for day 5 of e-learning. This is Algebra 1-2A. We're doing completing the square again today. So let's go ahead and get right to it so that we keep the video as short as we can. Please feel free to pause at any spot if you need. So going back to completing the square, we started with this last week on the part 1. Now everything on the other day turned out nice and neat, and you ended up with nice whole numbers. Today we're going to see some irrational numbers for answers, which, by the way, irrational means that it's a non-repeating, non-terminating decimal, like pi, or the square root of a non-perfect square. So, anyhow, b, just like we did the other day, we're going to have 3 amigos. We got b, take half and square it. So b is 8, half is 4, and then 4 squared is 16. So we're going to fill in the blanks here by adding 16 to both sides. Now when we do this today, again, we've used 8 to get started. We use the 16 to fill in the blanks. So this one should always end up being to complete the perfect square, we get a perfect square here. So factors of 16 that combine to 8 would be 4 and 4. So we get x plus 4 squared there. Now what's different today is that instead of having a perfect square over here, we get 17. So when we go to undo something squared, we take the square root, and we got the square root of 17, which 17 is actually a prime number, so there's nothing we can do to simplify that. So here we get x plus 4, and here we're going to have plus and minus radical 17, because anytime we bring the radical into the equation, we have to account could be a positive or a negative. All right, so that's our rule as far as that goes. Now, what's new today is that when we go to subtract 4, to go like this, we can't combine those. There's not like terms. Don't try to do 17 minus 4 is 13 or anything like that. It's going to be x equals. These are not like terms, so the best we can do is write negative 4 plus and minus radical 17, and that's it. We're done. Okay, with that one. We don't have to do anything else, at least as far as right now. That is simplified radical form. Technically, it's 2 answers because it's negative 4 plus radical 17. Also, it's negative 4 minus radical 17. Okay? So pause that if you need to get things down for your notes. But a lot of our answers today are going to look like this. I'm going to go ahead and a bit of a spoiler there. So there you go. All right. Here we go for number 2. You're going to see more of the same, really, with what we're doing here with part 2 of completing the square. This one we've got x squared minus 12x plus 10. Is equal to 0. All right, so some of you may be asking, why in the world is he even doing completing the square? Well, part of the reason we do completing the square is because why don't we just go ahead and factor these? Like the ones the other day you actually could have factored, but I wanted to show you that you can do it this way as well. There are 4 methods of solving quadratics. This is the third one. We did solving by square roots. We did solving by factoring. And then completing the square is the third one. We'll get the quadratic formula tomorrow. So if we tried to do a times c, are there any factors of 10 that will combine to 12? No, it's not possible because 1 times 10 would be the closest. You get 11. That's not possible. So this is where we have to do completing the square. So we're going to move the 10 over so that we get completing the square form. All right, so we're going to leave a blank here, negative 10 there, and a blank there. Okay? B this time. So now once we get here, now we're all set and ready to go. And it's okay that that's a negative for right now. We'll talk about what happens if we try to take the square root of a negative later. But here we get b is negative 12. We take half. And remember, negative 6 squared is equal to a positive 36 for our 3 amigos over here. Keep this negative here. It's important for this step when we use that. So don't neglect, don't leave out this negative 12. Don't just put 12 there. All right, so the 36 is what we're going to add to both sides. In the middle here, so we end up using this one. We've used the 12, we use the 36. We still get to use this one. It's going to be x minus 6 squared is equal to 26. All right, now that, so far, again, that's the same process we did the other day. We're taking 2 days on it because this is something that can be difficult for students. So try to do your best. I know at times it might seem a little overwhelming without actually having class, but hang in there with it. Do the best you can. Okay, for right now, that's the best we can do. To undo something squared, we're going to take the square root of both sides. We get x minus 6 equals, now 26. We could actually try to break this up. 2 times 13. There's no matches. So if there's no matches, we just keep it the same. We don't need to worry about that. So it's going to be plus and minus radical 26. Maybe later today or in the notes we'll see one where that does happen. But we add the 6. I cannot do anything else to combine like terms, so my answer ends up x equals 6 plus and minus radical 26. And that's it. Even though we could get a decimal with the calculator, we're going to leave it in simplified radical form. Okay? So there you go. There's number 2. And like I said, I know these are a lot to handle right now, but hopefully we're getting parts of the process down. The big thing, especially because we don't know what's going to happen yet with school, is just that we're making progress and picking up as much as we can and putting in the effort. Okay? All right, here we go. Number 3, x squared plus 20x equals 62. So we're going to fill in the blanks this time. This one's set up perfect. So b is 20. We take half. Now 10 squared is 100. So there's my 3 amigos. Again, that's b, take half, and square it. So the 100 is going to go here and here. Okay. So we've used the 20 got us started, the 100 we filled in the blank, so the 10 is going to be factors of 100 that combine to 20, are 10 and 10, so we account for the 2 10s by making it squared, because it would be x plus 10 times x plus 10. Over here we get 162. Alright, so to undo something squared, we take the square root, the radical and the square cancel out, we get x plus 10 is equal to, now 162 is, we can try to break this up. We end up with 2 times 81. And 81 you might recognize, hopefully, that is a perfect square. So here we end up with 2 times 9 times 9. We have a match. So as we did radicals last week, I know it's been a couple days, but hopefully that's a good review. We have a leftover radical 2, but this becomes plus and minus 9 radical 2. Okay? So that's what happens to the 162. If you skip 162 and if you just write it down here again and move the 10, you're not going to lose all credit on a test or a quiz or something, but we want to simplify it as far as possible. So now we subtract the 10. However, this is still 9 radical 2, so it's not a like term. So our answer ends up negative 10 plus and minus 9 radical 2. There you go. Okay, so that is number 3. Feel free to pause at any part, especially this radicals part is tough there at the end, but this process, hopefully, like I said, it's the same thing over and over, it's just slightly different numbers. Okay, so there is number 3. Okay, we'll keep things going with number 4 this time. We got x squared minus 14x is equal to a negative 55. All right, so b is negative 14, right? We're looking to fill in the blanks. So we want this kind of format. Take half is negative 7, and then negative 7 squared. Again, if you type it like this in your calculator, you'll be okay. If you just do negative 7 without parentheses, you'll get a negative here, which is not correct. We get a 49, so that's positive 49. Now what happens here, I think you guys are going to like this because it turns into less work. We still got to do this part. We get x minus 7 squared, but over here, negative 55 plus 49 is a negative 6. And now, whenever we try to take the square root of both sides, we can't take the square root of a negative right now. There is no real number. I know it sounds weird, but there's no real number that this will work. So this is what we call no real solution. Okay, and what I mean by that is in Algebra 2, we get into what we call complex numbers. We have the variable I, which represents the square root of negative 1. So we do simplify that later on, but for right now, no real solution, or even NRS is good enough for that one. So we cannot take the square root of a negative if that happens on the homework. Beware, that might happen once. So there you go, there's number 4. Okay, last one. You may have noticed that every single time B has been even. And even is good with complete square because When we find b and take half, it works out nicely. You get a nice whole number. However, looking at number 5 here, x squared plus 5x equal to -6. This one's kind of tough because, well, it looks like you wouldn't probably do this by complete the square. At least you could try to go a different route. However, and you could, the route I would go if you're going to do complete the square, it is just to show you it is possible. B is 5. Half of 5 is 5 over 2, which is equal to 2.5 or 2.5. So then we take 2.5 squared. Use your calculator. You don't have to do this in your head. You get 6.25. All right, so that's that part. Still doable. We just use the calculator. Now, when we fill in the blanks, though, we got to put plus 6.25 here and plus 6.25 there. The tough part, you wouldn't normally try to factor this even at all if it was decimal, but because we've already used this and this, we know now with this, just the whole pattern we've been doing, this is going to be x plus 2.5 squared, and that, we use our calculator again, we get 0.25. Okay? So we can still fill in the blanks as long as we know kind of what's going where, and then use your calculator. You don't have to do it in your head. We take the square root of both sides. Here we're going to get x plus 2.5. Now the square root of 0.25 is actually plus and minus 0.5. So then we go and subtract 2.5 minus 2.5. And let's see what ends up happening here. We end up getting x equals a positive 0.5 minus 2.5, or a negative 0.5 minus 2.5. And we finally, hopefully we have enough room here to fit this on. We end up getting a -2, or that one is going to be -3. Now, would this one probably be easier to factor? Yes, it would. But I wanted to show you one where at least you can do this with decimals, but this whole stuff that you end up with, that's why when this is odd, I would try some other method of solving. But it can be done. I had students do it in the past. Sometimes students really like this process. Other times they don't like this process very much. But it can be useful, and hopefully you guys hang in there with this. Hope everybody's staying safe. I'll be back tomorrow, probably with a different hat on, just so I don't get the days mixed up when I'm trying to upload these for you guys. So hope everybody's doing well. Hope your families are well, and take care of yourselves out there. We'll talk to you soon.